Okay. So we're going to work on this. All right. So it's Monday. Obviously, I'm moving very slowly and having all sorts of luck with the technology today. So just laugh at me in your head and go on. It'll be fine. Just don't point and laugh. That makes me feel self-conscious. All right. So let's talk about functions. We've been using functions. You know, you've been using the print function. You've been using the turtle functions to go right, left, up, down with pen. Those are all functions. So far, all we've done is used the built-in functions. I had to go pull this from last time I taught it, so ignore those slides and I will find the right slides because we've already done assignment 3 and we won't start talking about project 1 for another few days. All right, so we need to figure out how to use the stuff we've already learned, but we need to package it up in reusable chunks. So like you drew for this assignment, if you finished assignment 3, you had to draw a picture that had 2 squares in it. So you wrote the code twice, right? For drawing a square, whatever size you wanted. Well, wouldn't it be easier if you had a draw square function you could call, where you just put what size of square you wanted in there? And then you wouldn't have to write the code every time. You could just draw it. Well, one thing we're going to talk about that I didn't talk about when we introduced loops was accumulator examples. A lot of times we use loops to sum something up, so we accumulate a value. Now, you did this if you did averages, right? Okay, there's a few of you that are awake Monday. All right, so this is what we call an accumulator pattern or an accumulator example, because the loop is used to add things up or to accumulate values. Do you really need to know that terminology? Maybe somebody might ask you on a test one day a question about write me an accumulator loop. It's just a loop that adds things up. Now, for our intents and purposes in here, that's really all you need to know. This is an intro class. You get more in depth of different patterns and things as you go through. But just remember, if you ever see something that says accumulator, that they want you to total something up or add something up. And it's usually done fairly quickly with a loop. A for loop is great if you know how many items you're going to accumulate. We're going to talk about this week, but next week, while loops. They are great if you don't know how many. It does it until you run out of them. So we're going to start talking about functions or methods. I will interchange the 2 words. In Python, they're called functions. When you get to Java, they're called methods. It's basically the same thing. Different terminology for different languages. Sorry. So if I mix the 2 words up, know that I mean the same thing. And it doesn't help that I teach both languages at the same time, so I will often mix them up. So there's 2 things that I want you to always remember about a function when you're writing it. It does one thing, and it does it well. So it does a specific task, like draw a square. You don't want a function that draws a square and a circle, because that's doing 2 separate things that logically you probably only need for one particular program. But if you did a draw square and then did a separate draw circle, then those are 2 pieces that you might use repeatedly But if the two together makes it too specific or too defined to one task that'll never be repeated. So we want our functions to do a specific task, and we want them to be reusable. We're doing this to save ourselves time, ultimately. You're like, oh, I could just write the code for a square. Yeah, you could, but when you get to the project and I have you drawing dozens of the same shape, you're going to wish that you had a function for that. Actually, the project's going to make you have a function for that. But if you were drawing it on your own, and I have had people turn in the project with no functions in it, not good for your grade, but so it should implement steps from your algorithm. It should solve something in your overall plan. The benefits are that it is reusable, that you write it once, and then every time you need to use it, you just call that function. We're lazy. Programmers in general are lazy. So why rewrite stuff over and over again if you don't have to? And once you get that function working correctly, as code, you don't have to debug anymore. Once you know that your draw square is accurate every time you use it, that's a chunk of code you don't have to look at anymore. So when it pops up some error and you can't figure out what it is, you can just go, oh, not that one. I can go over here. Order of execution within a function is sequential. So just like what we've been doing so far, the lines of code are executing as you come to them. Well, when we write a function, the program's going to jump to the function, and then it's going to do them in the order inside the function, and then it's going to jump back. So they always are going to be in order. So you still have to be careful that you declare your variables before you use them inside of a function. You have to make sure that you do the math in the right order of operations, all that stuff carries over. It's just kind of like a little mini program inside of your program as far as how the order of operations. There are no constructors per se, and a function's not going to have a constructor, because the constructor is a function. We haven't really touched on that much in here, but the book has started talking about constructors, or at least it will in the chapter. So a constructor creates an object. So when you had to create your turtle, like when we did Alex equals turtle.turtle, that's the special function that we call it's called a constructor that created the object. And then the object can use all of the other functions to do stuff. Have I lost anybody yet? So this is the order for operations.
I'm sorry.
So the top line is our function definition. It gives the function a name, and if it needs parameters, you define them there too. This particular one is move in a box, because it's going to make the turtle move in a box shape. So all function definitions start off with the keyword def, because spelling out define or definition was just too long for the creators. So DEF is short for definition. So you have def, and then you have the name of the function. You can name your function anything you want. I'm going to tell you that coding standards for this department is to have functions that names that clearly define what the function does. This is also going to happen when you get a job. They want the functions to be easily identifiable for the next person on your team that's using them. So Again, same as variable names. If you want more than one word, use an underscore to separate the words out for readability because you can't use a space. The function name always is lowercase. Never starts with uppercase unless it's a constructor. Constructors are uppercase because they're special. Right? Special. And then it has open and close parentheses. This is where you would define parameters if it had any. This one doesn't have any. It's going to draw boxes of one single size. Because all the numbers are hard coded in. So somebody wrote in numbers. Now, if you ever get something back from me in your comments on your papers that said used hard coded numbers, that means you typed in a specific number and didn't use a variable when I expected a variable. Some of y'all got this on the names and the majors and stuff because you just kept printing your stuff out instead of asking you to input and print it. So ignore these numbers except for the order of operations. The 1 through 8 is just something I put up there to show you the order of operation. Or it'd be like your line numbers. So we're going to define it. Special case, again, when we define loops, when we define functions, we end the line with a colon. If it doesn't automatically indent when you go to the next line, you left the colon off. All right, so this then is going to have Alex go forward, left, forward, left, forward, left, forward, left in that order. This function is not really a usable function, not reusable, because it's very specific, of a very specific size. So it works for the use it was written for, but it wouldn't work later. A function can call other functions. How do I know that? Because the last slide just showed me that. This function is calling the turtle functions because forward and left are both functions Alex has access to from the turtle module. Our function is calling those functions. A function transfers control to the new function. So the program transfers control to the function you wrote when it's called. The function that you wrote, if it called other functions, pauses and transfers to that function until it's finished. Then it comes back and it does the next line. And this is really hard to wrap your mind around sometimes. Ooh. Pressure just changed in my head. Right. Because you have to keep track of what your functions are doing. And if the function isn't returning the value you need in the right place, you might have to change the order you're doing. So I have 3 functions written on this screen. And draw figure calls dash or move dash. Draw figure, move dash, turn left with a dash are the 3 functions here. The first one calls the other 2. So when I write the code in my program, I need to make sure I have defined the other 2 is going to call before I try to execute it. So if I did this, if I got to draw a figure and I put my turtle down and I want it to move dash, it jumps from there into that function. Let me make this a little easier. Here's your order of operations for this. So first thing I'm going to do is number 1. And then I go to 2 and I call the dash. 2 then brings me down to 3 down here. Right? That then takes me to 4, 5, and 6. Then I jump back up to 7. I call another function, which takes me over here to 8, 9, 10. Oh, that caused it move dashed again. So now I'm back over here and I do 11, 12, 13, 14. Jump back over here to 15. Finish this function and go back to 16. I see some nodding, so a few of you followed all that. Do I expect you to understand this 100% right this second? No, but I want you to look at it and think about it. But what it basically is saying is that once you call a function, the program jumps over to that and gives control of the actions to that function. When that function is finished, it gives control back to the next line after it goes back to where it started from. Back and forth, back and forth. So remember that a function definition in general looks like this. It's DEF, the name of the function, and whatever parameters it needs. So if we were doing draw rectangle and we wanted to be able to tell it how tall and how wide it was, I could give it parameters like width and height. And then every time I called it, I would just put those numbers in. The example of this is go to for your turtle. We gave it an X and a Y location when we wanted to go somewhere. So that function took two parameters, took the X value and the Y value. Front row's with me, they keep nodding. This edge of the room nods. Yeah, okay. And then you have statements, and like the for loops, all the statements that belong to that function are indented in. Indentations, indentations, indentations with Python. The more colorful version of it. So this function in this example has two parameters. It takes a name and a message, and then it can print out those things inside the function. Function parameters are, you can use input statements to gather that information. So then it's more usable. Your user enters information, you take that information, put it into variables, pass those variables into your functions, and now it's a user-driven program. Which is very good, because ultimately that's what you all want to do is work for companies that write software. Well, maybe not all of it, but a programmer generally wants to design software that's user-friendly, that users are going to use and want to use because it gives them something they need. Even if you're designing video games, you have user inputs, so you have to tell your character where to go and what to do. You may not be typing out stuff, but you're clicking those mouse keys and you're clicking those keyboard keys and you're pushing buttons. I obviously play PC games. I don't know about the controllers. Don't ask me what the buttons on the controllers do because I don't have a console game. I'm old. So return values. Functions can give information back to your program. So you can have a function called calculate average, and it passes in a list of numbers. It sums them up, divides them, and then just returns that average. And every time you needed to calculate an average, you could use it. But remember, it can only return one value. If you can't calculate the average and the standard deviation in the same function and pass them both back, you can only pass one piece of data back. Guys. So, does that make sense? Now, somebody's going to say, but what about a list? That's more than one. To the computer, a list is one data structure. So that's one piece of data it's turning back. Right? One item gets to go back. That's it. So I've got some examples in the slides. So if we got get distance moved, you can pass in the size and the steps, and it will multiply the size by the steps. It doesn't math every time, you don't have to call it. Luckily for us, a lot of the math equations are in the math module, so you never have to reinvent the wheel and figure out how to get the square root of something. We can just call the math module and do that. You can do some math, some simple math with your parameters, in your parameters. I usually don't because I always forget what I've done. But if I wanted to, I could go ahead and say, well, I need to do 3 times b. So I'm going to do that math in the parameter list, and then I'm going to pass it in. If you do multiplication, division, adding, subtracting, that sort of thing in your parameter list, it's going to do that math first, and it's going to pass whatever the answer to that math equation is as your value. You'd be amazed the amount of stuff you can do on one line of code. If you really are up for a challenge and want to see how many function calls you can nest inside of this function. I don't do it because it's clearer to read to me if I do individual things on individual lines. You're welcome to give it a shot, but be aware that you're going to have to check yourself pretty carefully if you're putting a lot of steps in one single line of code. I would not do this. I would not do b times 3 in a parameter list for the most part. I would probably do that math first, put it in another variable, and pass it in, especially at this level. You're just learn to use the code first, then get fancy. Can you read this slide back there? Okay. So these are just some more examples. I'll put the slide deck up and you can go look at it. But it's just showing you again how to call functions and how you can pass in parameters and what parameters do. Anybody have any questions so far? The only thing you have to remember about a function inside of your Python file is that you have to define it before you can use it. Which everybody's going, well, duh. But what I'm trying to say here is you can't decide, oh, I'm going to put all my function definitions at the bottom, and then at the top, I'm going to use them. Because if you haven't defined them, you can't call them. So you have to define them first, then you can call them. Now, we are going to do a special function that we're going to start learning about called main. And inside of main, you can do all your function calls. And main can be anywhere you want it to be because the functions will be defined before main executes. I usually put main at the top. A lot of the Python examples put it at the bottom. Personal preference choice for you guys, as long as you remember that there's only one main. Let me say that 15,000 times. There's only one main function ever in your code. Last semester, I had a lot of people that were using multiple main functions. And oddly enough, Python will let you get away with that because it'll run the first main it comes to, and then it'll go down and it'll run the second main, and it runs them independently. So it doesn't necessarily do exactly what you think it's going to do unless you really partitioned off your stuff really well. It works okay with print statements because this main is going to print off all the information you need. But if you were storing stuff in a file that you needed to use later, it might not work as well. One main function. Importing a module. So we imported Turtle. If you're going to use a module, like Turtle or Math or any of the pre-fund, you have to import it before you can use it. A good rule of thumb that I use is I always, even if I realize midway through coding that I need an import statement, I always move those to the top of the page. That way they're always imported before I need them. Even if I'm 3 pages into writing code and I go, oh, I need Math now, let me import that. You could put it right there and import it. But it just is cleaner and easier to read if you move it to the top. And that way, if you ever make any modifications above the import statement that uses Math, it still works. Right? So you'll find that there's a lot of patterns to coding. And some of them are what we call guidelines or suggestions, for lack of a better word. And some of them are hard and fast rules. Coding styles pretty much are guidelines. But you need to learn them because when you move into higher level coding classes here, you'll lose points for not following style guide. I'm not as strict about that because you're just learning. But I figure everything I teach you now helps you in the next step. So just a good rule of thumb, import statements, put them all at the top. Pay attention to where your professor or your boss wants the main functions to be, top or bottom. Follow their lead, and it will make your life and their life much easier. When you get hired in a coding position, they're going to show you what they expect, and you have to keep up with it. The Java class requires you to have a very specific set of comments. Every time you write a method in the Java CS1 class, you have to put comments at the top telling them what the method is doing and what the parameters are doing. And I'm not going to get that detailed in here. But I'm going to start getting you in the habit of every time you write a function, there's going to be a comment above it that tells me basically what you intended for the function to do. Now, whether it successfully does it or not, I'll be the judge of that. But it comments. And when you start writing code, we don't do it in here, but you will eventually start putting a comment at the top saying basically what you think the program's going to do or what you intend for the program to do, and your name as the author. And if it's something that's going to be revised, you put the version number. Because you want to get credit for your work. You're like an artist here. You want to sign your work and put your name in as the author of this code. Now, will some people steal it later? If it's good code, probably. But you want to get credit where credit's due. And if you're writing code that's good enough to steal, that means you're good. Right? Now, don't do like some other students who decide to cheat poorly. I had a really bad group several semesters ago that decided that they would all cheat off of one person. Unfortunately, they didn't choose the top of the class student to cheat off of. So it was really obvious when they all turned in the wrong thing exactly the same. So I personally think you waste more of your time trying to cheat than it would take to do what I asked you to do. You'll spend a whole lot more time looking on the internet for the answers for a lot of stuff than it would take you just to do it. But if you don't learn it here, it's going to show in your next class. You're only hurting yourself. And you're paying for it. Go figure. Or your parents are, or somebody is. All right. Moving forward. I'll get off that soapbox. We have a lot of cheating happening lately. Local variables to a function. If you define a function and then you put define a variable, you only use it or you only defined it inside the function, it belongs to the function. And once the function's over, unless you returned it, you can't use that information outside the function. Remember the for loop? I told you if you created a variable inside the for loop, did it reset every time you ran it? Same deal here. This is called scope. So the scope is how far or what parts of the program does a variable belong to. The scope of a variable inside your function is local. It's a local variable. It only belongs to that function. The parameters you define for the function, those parameters only belong to the function. Now, this is good and bad because that allows you to reuse variable names. And as long as you remember that width and height for the rectangle belong to the rectangle, you can also have width and height for a triangle. Use the same words, but they belong to different things, so they don't necessarily transfer. So you can't just type in 10 for width and it go to the triangle and to the rectangle. They're specific to their individual functions. So if your function is doing the average, you're going to return the average and put it into a variable inside the code itself where you can use it later. Now, if you do something like have a function that's drawing something, you don't have to return anything because it's drawing it to the screen. But if you're doing math and you don't return it and you don't have a print statement, then your program will have done it, but you'll never see it or never be able to use it. Be careful using the same variable name in multiple functions. You absolutely can do it. Just don't confuse yourself. You know, if you were doing things that had a lot of widths and a lot of heights, you might want to go triangle height, triangle width, square height, square width. And I'm using overly simplistic examples, but I'm just trying to get a point across. And what we're doing here, you probably aren't going to get confused because we're writing stuff that is relatively short. But if you were writing thousands of lines of code and you have hundreds of functions, you might want to be clear on your variables just so you don't forget. So I hate using A, B's, and C's. This is not math. Variable names should not be A, B, C. Because they're not clear. If I come back a year from now, I have to go and read all the code and figure out what A, B, and C really were. So my examples are using A, B, and C, but it's not a good practice. So my function takes A and B, and then I can use A and B inside the function. So this is inside the function, this is outside the function. So I define it here. Oops. I defined it here. And then later on I go A is equal to 3, B is equal to my function A 4. So this is going to call this function and return this value. And then it's going to print A. So what happened to B? It did stuff, but we didn't ever use it. We didn't print it out to the screen. We saved it, but we didn't display it to anybody. I'd have to run it and test it to see if it actually worked. Does that make sense? Okay, so here's our special one, the main function. You can think of the main function as the driver of this car. It's going to lead the program from here on out. So far, we've just been typing code in our file. Great typing. That's not happening anymore. After I explain this, everything will be inside of a function. If it's not a function you define, and it's just lines of code, it'll be in the main. But nothing should be outside of a function from this point forward. And if you do have code that's not inside of a function from this point forward, you're going to start getting comments in your grading that says orphan code because it doesn't belong to anybody. You just left it out there to fend for itself. Will Python run it? Yeah, unfortunately, Python will still run it. I made this joke several when I first started. I called Python loosey-goosey coding because it assumes it knows what you want to do and it makes some judgment calls for you. This will not follow through in other languages. So we're going to break bad habits now. Yes, ma'am. You're good? Okay. So, the first couple of times I'm going to slap you, theoretically, figuratively slap your little hands and say, no, don't do that. But after a while, I'm going to start going, no, you can't do that. And I'm going to start taking off more points. So just like with turning in the files, if you turn in the wrong file the first couple of times, I sent you a message that resubmit, I'll regret. Same with this. I'm going to say, no. I'm going to dig you a few little points here. Don't do this anymore. This should be where, now I'll tell you what should be. After I've done that a couple of times, I'm going to just go orphan code, -5, whatever. And also, if you continue to turn in things at this point that don't actually run, if I press the run button and I get a big red error, I'm just going to put a 0 on it. Send it back to you. Up until this point, I've been opening them up, figuring out what's wrong with them, running them, docking you a few points, telling you what you did wrong, and going forward. If it doesn't work, the last thing you're working on doesn't work, and it stops the program from running. But the rest of your code works. Comment out the broken part where I can at least grade what does work. Yes? Don't delete it, because I do open every file and look at them. And if you got stuff that's commented out and you got a little line of it says, I worked on this for like 3 hours, but I couldn't get it to work. I usually will grade, look at it, try to figure out what's wrong with it, and try to give you some partial credit for it. But if it doesn't execute, I'm not grading. Because it's time to learn that everything has to execute. All right, so you'll hear the word execute a lot. That's the same as run. But the entry point and the driver of your code from here on out will be the main. So you write all your functions and you test them in main. You get all your user input from main. So your input statements most likely will be in main. Or you'll call a function in main that goes and asks for input. But all your function calls for everything you write will be in main. So main is a predefined starting point. Almost every language that I've written in has main or their version of main. The only thing HTML doesn't so much, but Java has main, Python has main. Main is going to be the driver. But we only have one of them. If we were writing different modules, we would still only have one main. You get to Java, and you have different classes, you have one main, not one per class, but one main per program. So we're going to write a function. Oh, I don't like this example. It's got lots of math in it. Let's do it. Let's do this one. We're going to write a function called draw rectangle that will allow you to pass a turtle, a length, a width, and a height into it. So what we want to do is we want a rectangle that's going to use a specific turtle to draw some rectangle with a width and a size that we're going to have the user or the code execute. Don't start typing yet. If you're typing code, don't do that yet. So what I want you to learn from reading this is how to figure out what you need to get started. So if I'm reading this, I've already told you what the name's going to be, right? I've made it pretty obvious in this what the name's going to be. Because I put an underscore in it. That's obviously not me typing for my benefit. And it says called this. So if you're reading my specs that I give you for like projects, homeworks, whatever, I expect to find exactly this name because I told you that. Now, if you need to pass it, if it says pass, that means you need a parameter. I'm trying to give you keywords here to look for. Because the project definition is about 6 pages long. So if I need to pass information to it, that in my head says, okay, these are probably going to be parameters. And then I look at, okay, I need to pass a turtle, that's 1 parameter. I need a length, that's 2 parameters. And I need a width, that's 3 parameters. Can a function call have 3 parameters? Absolutely. You can have 10 parameters if you wanted to. A little hard to keep up with what they all are. Now, once we know those parameters, now we can look at, okay, what am I going to do with those parameters? Well, I'm going to draw a rectangle with them. Now, the good news is we don't have to define all the different functions for the turtle. Since we passed in the turtle, we passed in all of its functions with it. So forward, left, right, all that stuff, it's going to work. So what you would have to do before you use this function is create a turtle with a name. And then when you use the function, you would pass that name in, right? So if I was writing this, I was writing this, I would go in and I'd do DEF. I need multiple screens. Draw a rectangle. And I need a turtle, a length, and a width. Parameter names, I'm making them just as simple. If it's length and width, I'm calling them length and width. If it's a turtle, I'm calling it turtle. Don't overthink it, but make them clear. Right? And because I put the colons in, it automatically indented to where I needed to be when I hit enter. Now, what do I need to do to draw a rectangle? I need my turtle to go forward, length, and because I'm lazy and I know that we're going to do this over and over again, copy, paste. Right? Now, because it's a rectangle, this one needs to be width. That makes sense? Now, I probably would change, I know the example said length and width. I probably would change it to height and width because that to me visually makes more sense. I went up and down. And then, but it doesn't really matter as long as you alternate them. And when you call it, you put them in the right order. Now, does this make sense? And every time I want to draw a rectangle now, I can just call this and give it those values. Now, if my turtle's name was Alex, when I called it, I would put Alex in there, and then everywhere turtle is in the code, it would be replaced with Alex. And if I put 5 in as the length, everywhere the word length is, the value there would be 5. It's a simple substitution, variable substitution. So, guess what we're going to be doing this week in lab and our assignments? We're going to be rewriting our turtle stuff using functions. Now, my math majors, what's the difference between a rectangle and a square? What? Okay. Okay, 3 is not the answer to that question. All right. So rectangles have 4 sides. Squares have 4 sides. A rectangle has 2 sides that are equal, and then 2 other sides that are equal. A square has 4 equal sides. So do I need to have a function draw square and a function called draw rectangle? No, because I could just pass in the same width and height and to draw a rectangle. There's no point in reproducing code if I already have it, right? Because every square is a rectangle, but not every rectangle is a square. My math majors are going, yeah, we've heard that before. So there's no point in having a draw square and a draw rectangle. Just do draw rectangle and know that you're passing in the, making them equal. I'm saving you coding time. But moving forward, we are going to be drawing our own functions. So on your, I really need to get next. So the next thing we're going to do is talk about documentation and design principles. Forget the exam 2 and all that stuff, because like I said, these are last year's slides. I gotta go find this year's slides. I don't know where they are. But be aware that we got that going on. Still don't understand what's going on with my code, but we go back to our class. I don't know if Coursera lets you go back years and years like mine does, but okay, that's actually next week's stuff. All right. So I will fix that in Coursera. So I'm pretty much done with new material for today. Does anybody have any questions for me? Yes, ma'am. All right, wait, stop moving where I can hear. You have to define the function for you. No, go ahead and import the turtle first. I would do the import at the very top. All that says is by doing the import statement at the very top, all you're doing is preparing your program to use it. Program is, oh, I'm going to go ahead and import all this module because I'm going to use it later. So I would do all the importing first. Any other questions? Yes.
Why do we have the turtle as a parameter for function? Couldn't we just make it a local variable considering the name of the turtle? You have to actually kind of just...
You could, but if you get into a situation where your evil professor says, "Hey, you're going to have 3 turtles. Each turtle's going to do a different thing," then no, it wasn't going to work that way.
Oh, okay.
So assigning a specific turtle to do something is why you need it as a parameter.
Okay.
Oh, I see you go red on your screen. Somewhat around here. This should be up. Why is it data? It's definitely on the other side of it now.
Oh, you were listening to the show?
I sound on.
I love you.
I used to make.
That looks crap. I probably would not use it for. I know the internet. You can never store it.
We'll get this.
For assignment for student three, are you on like for instance the seasons and then have the months put inside the season? Like what exactly is going on?
I just wanted to print out that list of 4 seasons.
Right.
Please stop overthinking.
No,
This is
it's
your
because
life.
you wanted part of the thing that said print out the lines.
It's a typo. Well, you don't have to tell me it's in there.
Like I like
Because what it is I have to change my assignments every so often where people don't just say, oh, I had a class last semester here. So sometimes I have them print out the months, the year, sometimes I have them print out the seasons. I just missed it when I was.
Print out the month of the year and then it says right below that, print out the season.
Okay.
It's very.
Well, you just- Well, then email me. No, you're not, I'm just being more fun. You said you should. So in your print, you're gonna say, whatever your words are in the quotes, and then you're gonna have a plus sign, then you're gonna have the string and the variable from the loop. And another plus sign, so it'll print words or number, and then it'll print more stuff. Check the book, that's why you have a book, it'll tell you to do something. You'll find quotes. I'm giving back to you.
Yeah, I know.
Okay, so what's the area again?
It was something along the lines of what I do.
This is where that hint comes in, because you have to change it from the integer to string. So there's a function. If you put right there. So str. Open. Parentheses. We'll convert it. It's a Python. And Java doesn't make you do that. It will just print the number.
That's more. That's fine.
Yeah.
Thank you.
This is one of the quirks where Python is actually not as helpful as Java. So, yes.
Yeah.
Yes, sir.
For the assignment, I ended up for the first part, I took the seasons and assigned them to a variable year and then had 4 seasons in year here print in season. I know that they can print the file text directly from a list. I'm not sure if you want to change that.
As long as it prints out the 4 seasons when I write it,
Yeah.
you're probably fine.
It prints out the 4 seasons.
You're just doing stuff that we're not
we're doing things that we haven't learned yet, but as long as it, I don't specifically tell you that you have to do.
Yeah.
Yeah, if I specifically say, use a for loop, then I'm looking for a for loop. If I don't specifically say, then you can do what you need to do.
All right, fair enough. And also,
Uh-huh.
firstly, the loop